What's up? What's up? Welcome to my live. I think I'm live. Yeah. Welcome to my live. Doing another coding challenge tonight. Appreciate you people joining. I'm not gonna take too long to jump into it. We're doing a coding challenge again from Leetcode.com. This one's called First Bad Version. It's an easy problem from Leetcode.com. And yeah, without further ado, I'm just going to jump right into it. So this problem is called First Bad Version, and it goes as such. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check since each version is developed based on the previous version. All the versions after a bad version are also bad. Suppose you have n versions, so 1, 2, 3, 4, 5, 6, 7, 8, all the way to n, and you want to find out the first bad one, which causes all the following ones to be bad. You are given an API called isBadVersion, which returns a boolean and you can input a version into it, which returns whether or not the version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API, and the API will be isBadVersion in this case. So that's the problem description. Looks like Instagram is kind of acting funny, but hope you guys can still see me. But yeah, that's the problem description, and they have an example here saying, so if n is 5, so you have 5 versions, 1, 2, 3, 4, 5, and the bad version is 4, then if you call isBadVersion function on 3, you get false. If you call it on 5, you get true. You call it on 4, you get true, because 4 is the first bad version, so then that means 5 is bad too. Anything after 4, anything after the first bad version means the rest of the versions are bad too. And so it's an example here, if you just have one version and that one version is bad, then you just need to output 1 as the first bad version. And then in this one, 4 was the first bad version, so you output 4, and that's how you answer the problem. So I hope that makes sense. Yeah, I'm live on Twitch. Somebody asked if I'm live on Twitch too. Yep, live on Twitch, Instagram, Facebook, YouTube, everywhere. TikTok, everywhere. So yeah, and then there's some constraints down here. 1 is less than bad, is less than n, is less than 2 to the 31st power minus 1. And so bad is guaranteed to have some bad version between 1 and n is probably the most important part here. So, all right, that's a mouthful. How do we do this problem? So like I always start these problems off, how I like to think about them is I think about them in my head first. How would I solve it kind of in my head, or with pencil and paper, or with the keyboard or whatever. But I try to solve it in my head first before I jump straight into code. And the first thing that's standing out to me with this is I need to find the first bad version. I have an API function here called isBadVersion that I can use to do that. So the first thing that jumps out to my mind is simply to just loop through 1 through n and just test this isBadVersion on it. And I mean, to me, the first thought of it to me is that that's going to take a lot of time is if n is really large, so it doesn't feel optimal. But that would be my first thought, kind of like a brute force solution. That's what will be called a brute force solution. I'm literally trying every single one of these options to figure out which one is the first bad version and simply return it. So is that the most optimal solution? No, it's not the most optimal solution. Somebody in the comments already commented the most optimal solution, but for the sake of learning, I'm going to do this solution. It's the first one I could think of. And if you're in an interview setting or even in a regular work scenario, you may try to just get it working first and then try to optimize from there so that you just get something down and you can learn and you can grow. But shout out to Cashmoo. He already knows, he's a pro, so he already knows what it's supposed to be. What language are we using? I'm using JavaScript. I do all these problems in JavaScript. And right now, in this point in my life, JavaScript's my strongest language right now. So I use it for almost everything right now. But it's not the only language I know, but it's definitely one of the strongest I know. So let's jump over to code and just do our first thing that came to mind. If just say I couldn't think of anything else, this is just what I could think of to do. So let's do this solution, because if you're in a situation where you can't think of some more optimal way to do it, you're going to have to do it using what you know and what you can think of. So for people that are just joining, the problem statement is up here at the top since I've slid it over. So if you want to just catch up if you're just jumping in. But I'm going to try my brute force solution now. And what did I say, kind of how to do it in my mind? I know I need to find the first bad version out of 1 through n, whatever n is. So I'm simply going to try every single version with this API until I find the first one that returns. And shoot, what is it supposed to return if it's bad? Yeah, isBadVersion supposed to return true. So I'm going to find the first one that returns true. So how can I do that? If I have Leetcode gives you this function, this stub that allows you to fill out the function so that it'll work based on what the problem is supposed to be. And so to do that, and I don't know why Instagram is acting crazy. I might have to stop it and restart it, but I'm not worried about it. Please just join me on some other channel if Instagram isn't working properly for you. But anyway, so to do this, to basically loop through n, I'm getting n passed in. So n could be some variable. It could be 1, it could be 5, it could be 1,000, it could be 1,000,000. And so what I plan to do first is loop through n. I need to loop from 1 to n. So how can you do that? With a for loop. So I could say let I equal 1. That's my first number. While I is less than or equal to n, which is my last number. And then I'm going to iterate I every single step of the way of this loop. And make sure everybody can see that. Yeah, you can see that. Let me stop Instagram and start it again. Yeah, I don't know why it's doing that. Yeah. I have no idea why it's doing that. But I'll start it again. But yeah, anyway, so I'm looping through 1 through n. And what did I need to do there? I basically said I need to call my isBadVersion function. So that's the function that they gave to me here. So they gave it to me, which like the problem statement says that you are given an API that returns a Boolean to tell you which one is the bad function. And I need to figure out 1 through n, 1 through n, which one is the bad version. So what I can do is I can pass in every step of my loop, I can pass in I and check if it's the bad version. So I can say isBad equals this Boolean one. And so really what I can do here, since I want to know, I just want to return the first one that's bad, I can just say if isBadVersion return I. And so that I'll loop through in order and I'll return the first version that is bad. So this seems pretty simple, right? Like it seems like, and then here I can just return like no, because I should never, as long as I always know I have a bad version, I should never get to this point, because this problem is guaranteed to have a bad version. So yeah, it seems pretty simple, right? Like this makes sense. It seems like it works. This will get you a solution, somewhat of a solution. And it also, like on Leetcode, the default cases, it passes properly. So, but is there something wrong with this? And some people are commenting, especially on TikTok. They are letting me know like, hey, there's something else you can do, which is, yeah, that's correct. But just for sake of learning, going through this first solution first. And so, but yeah, the test cases work. But what is wrong with this? So I'm going to submit this to Leetcode. Leetcode is going to run it through a lot more test cases than these first two. These first two test cases was like only 5 and 1. So, but what happens when n is 1,000,000 or when n is 1,000 or when n gets really, really high? When I have to loop through thousands or millions of versions to find out which one's the bad version. isBadVersion could be an expensive operation. Even if it's not an expensive operation, it could start to make my algorithm really slow as n scales up. And so that means this algorithm I have is not a scalable algorithm. So when I run it against all the test cases, you can see it's taking a long time to judge it. And I know this is probably going to fail because usually if it takes you this long to run something in Leetcode, you usually have failed. Oh, shoot, it passed. I can't believe it. Well, that's not supposed to pass. I don't know why that's passing. But even though it passed, I only beat 5%. It took 10,000 milliseconds to run, which is crazy. I'm surprised Leetcode didn't fail it. I honestly don't know why Leetcode didn't fail it. That was weird. It's supposed to fail it. So, but in the interview setting or in real life, if you were running this and n could grow to any size, you would either probably fail the interview, or you would fail in real life because like it wouldn't scale properly, and you could have scalability issues. Like this is what algorithms are about, and this is why we do this stuff. So somebody said the Leetcode, Leetcode runtime statistics are unreliable. They are, but in this case, I think this is correct. Like beating only 5% is because I'm running a very inefficient algorithm. Memory makes sense because I'm not using much memory, if any at all. As far as like memory that scales with n, I'm not using any. I'm just using constant variables. And what I was gonna say, somebody said the Leetcode shan't get an update. Yes. So it does look very nice. It looks nicer now to me. Leetcode did this like maybe a couple weeks ago. But anyway, to get back to the problem, because I want to finish this in a decent time. Let me go back over here. That wasn't supposed to be accepted. I honestly don't know why. But anyway, let's think about this. Let's think about a way we can do this more optimally so we can get a better speed as far as time complexity. Because right now our time complexity is big O of n. It's linear time because for every n we have to call isBadVersion on it. So if n grows to 2 to the 31 power, or whatever that is, I don't know what the heck that is, but 1 billion, 1 trillion, I gotta run this function 1 trillion times. That doesn't make sense to do, especially since I know that once there's one bad version, every version after that is diluted is a bad version. And I know before the bad version, every version before that is clean. So that means, and the versions are in order. They're sorted in not alphabetical, but numerical order. So what that means is we can use a certain algorithm for this. And a lot of people are saying binary search. People have been saying that ever since I jumped on here. Yes, that binary search is what we can use. That is something that, you might not know that off the top of your head. And I know a lot of folks say these interviews like that have these type of questions. You're supposed to just know this stuff and it just pops up to you. That's not the case. You got to know these algorithms. Like you have to have studied some of these algorithms. Like you're just not going to just pull binary search out of your butt. And so the one thing about binary search is that when you have an ordered data set that is ordered in alphabetical or numerical order, and you need to search for something in it, then binary search is a very efficient way to search that out, that input without checking every single element in it. And that's because it's ordered. So whenever you see a problem on Leetcode or in real life where the input, you can order it yourself before you process it, or it's already ordered, good chance is if you need to search for an item in it that you should use binary search to be the most performant. And that will, instead of log big O of n time, that will give you big O of log n time, which is faster than big O of n time. That means you're searching this input not linearly every single value, but you're searching it in like almost half the time. So basically what binary search does is that you split your input on every iteration. You search it in iterations and you say, I'm going to check the middle of this input, and if what I want is higher than where I'm at, or if it's lower than where I'm at, I'm going to only look at the left side, or I'm only going to look at the right side based on whatever I'm trying to test. And in this case, I'm trying to test whether the version is bad or not. So I know if once one version is bad, the rest of them are bad. So I can know by looking on one side whether or not, if I find a bad version, I know that all the versions to the right of that version or to the behind that version are bad too. And so that's going to help me with this binary search. But instead of talking about it so long, I'm going to jump back into it. And so you can go and look and research binary search. I know a lot of people in the comments already know what it is, which is great. But yeah, a lot of people don't know what it is. I didn't know what it was, forever. So I think it's good to do that here. So instead of doing this inoptimal solution that gave me a really bad performance, which was, I can probably type it here, what my old performance was. It was big O of n, which was bad. Once the value of n went up very high, I can do a binary search. How do you do a binary search in code? Like I talked about, how you you're splitting your input at every interval. Well, you have to loop to do some sort of intervals, but how do you split your input? So binary search is probably something you should memorize how to do in code, but you should understand it as well. But at a point, you're going to get to the point where you're going to pretty much have it like memorized. And so what I know about binary search is that I need a start index that is at the start of the input array. And then I need an end index. And in this case, it don't really have to be, you can name these whatever you want. You can name them left and right. You can name them start or end. People do it in different ways. But I know I have an input, and this is actually supposed to be 1. I know I have an input of 1 to n, and I know my start index needs to be at 1, and my end index needs to be at n. And I'm gonna show you why that's the case very soon here. And so now, to loop through this, I actually want to do a while loop this time. And this is going to make sense soon, but I want to, while start index is less than end index, I want to loop through this array. And it's basically n is not an array, but n is a value. But since it's just the numeric value, I can inherently loop through it just by iterating some pointer from 1 to n. And so I basically want to say, wow, I'm gonna be moving start index and changing end index. So I want to say, while start index is less than end index, keep this loop going. And while I'm in here, I'm gonna be changing these, so eventually this while loop will terminate. And that may be a little confusing to some, it may be obvious to others, but it's gonna make sense while I'm doing this very soon. And so in the spirit of binary search, the first thing you do in binary search is you're looking at the range of your input at a given time. Right now, we're looking at the whole input. One pointer, the start index is at the start of the input, and the end index is at the end. So start at 1, end index is at whatever n is, and n is a variable, so I set it to n, the variable n. And so what you want to do is you want to look at the middle index. And it's like already knows I typed this before. I don't know. I guess I did this before. But so how do you find the middle index between start and end index? There's multiple ways you can do this. this is how I do it in JavaScript. Math floor. This will be a calculation you need to kind of like know how to do. So I know that if I subtract my start index from my end index and divide by 2, dang, I'm starting to run out of like room here. Let me see if I can make this smaller for y'all or something. Yeah. Index divide by 2 and then add start index to it. And yeah, this is starting to, let me see if I can like drop this down a line or something. Yeah. So I know if I do math floor, which is going to give me, if I have a decimal value, it's going to give me a whole index value, a whole int value below it. That's something you need to kind of know. I won't go through and explain all of that, but basically I'm subtracting end index from start index to get that range, dividing it by 2 to get the middle of that range, and then adding start index to it to it kind of pushes it along to get it to the correct middle. It's kind of hard to explain, but this is something you want to like just know how to do, how to find the middle index in an array. Like it's kind of a common skill you need for algorithms for sure. And there's different ways you can do this. You can do start index plus index divided by 2 with math floor. There's a bunch of ways you can do it. And so I'm sure people got comments of like how they do each, of how they personally want to do it. So what I do now that I have the middle index, so now what I want to do is say my function. I want to use my function isBadVersion on the middle index here. And based on that, I want to do a couple different things. So if my so let's think about the problem. If my bad version is in the middle, so let's look at it like from this point of like we have good version, good version, good version, good version, and then bad version, bad version, bad version, bad version, bad version, bad version, bad version. So let's say my start is here, my end is here. So my middle is going to be, if I add one more B, my middle is going to be here. And so I'm going to put like some things around it. So I know that this is what I did so far is I said start index equals 1, end index equals n. In this case, this is this last one. And I found the middle index, which is this one, using this calculation. And so now I'm going to run this isBadVersion function on it, which was given to me. So I didn't need to do anything there. It's just something that Leetcode has that it will run and tell me which one's the bad version based off of some preset problems that they have set up on there. And so I'm going to run isBadVersion on middle index. So what if middle index, in this case, what if middle index is the bad version? So if middle index is the bad version, I need to remember what to do here because I actually forgot. If middle index is the bad version, then I'm basically too high. So I'm basically too high in this point. And so I need to move my end index. So end index, I need to move it. I want to set it equal to the current middle index, because I haven't found, what I'm looking for is the first bad index. This is not the first one, or I don't know if it's the first one or not. So at this point, so I know that I need to basically say this is, yeah, I need to move my end index to here, because I don't care about this anymore. If this is a bad version, I know none of these are the first bad version because this one is ahead of all of them. So there's no way these can be the first bad version. And so in the spirit of binary search, I can basically rule all of these out and get to here. And so now my new start and end are here, and I've narrowed my input. And this is why this search function is so fast, binary search. Binary search is used like with indexing database. If you think about a database, has a ID, usually incrementing ID. And if you set an index on a database and it orders your IDs and you need to search for, let's say, user ID 23 out of 1,000 IDs, if it's ordered properly with an index, or there's an index set that is ordered that you can use to search your input, then you can it makes for a faster search in your database. So like binary search is something good to know because it works for more than just problems like these. It works, you know, in a rudimentary version of like a database with an index set on it. So just to give some extra color or I guess information on that. So yeah, I moved a position there. Next I will come back through my loop again, and let's say the next time I come through here that G, I find the middle, I'm finding the floor. So it's gonna, if this is an even number of inputs, when I find the middle is here, and I'm gonna pick the first one basically. So it's actually a good version. And so isBadVersion will come back as false, and I will go here. And in this case, I'm not yet to my first bad version, so I'm like too far behind. So I basically need to move up my start pointer to middle index plus 1. And so like this is maybe a little confusing part, like why do I do plus 1 here and why don't I do plus 1 here? And that's because it's just logically because I'm trying to find the first bad version and not the last good version. So I need to increment, I need to set the middle index to plus 1 for the start index, and I can't do like minus 1 on the end index because it might be my actual first index or first bad version. It's a little confusing, but it makes sense, like, so you're not like off by one variable at the end of this loop. And so in this case, I'm going to change my middle index to middle index, or I'm going to change my start index to middle index plus 1. And so I'm basically erasing all of this in my search. And then the next time I come through this loop, my let me see. Yeah. So next time I come through this loop, my middle is going to be right here. And so I'm going to basically say, is it a bad version? Yes. And I'm going to set the middle to here. And then when I come through this again, then I'm going to start less than end. Yes. Then my middle version is going to be here based on the calculation. And I'm going to make start index middle plus 1. So that's basically going to make my start index and my end index the same. And so I've basically found at this point the first B by erasing that. So if you notice, I erased the last G and got the first B. So now when I get here, both start index and index in index are both my actual first bad version. So I could actually return either one of them at this point, but I'm just going to return start index. And I know this could be a little bit confusing, of course, like, but I hope it makes sense. This would be something that if you practice it enough, it'll just click for you eventually. I promise. If it feels like it's just like impossible, please research binary search. Research this problem. It's called first bad version. It will make more sense. But I'm hoping with this first time explanation that I'm helping somebody out there in the world out, as I'm helping myself tighten up on this stuff as well, with my professional work as well as just being, prepped for any time I plan to eventually interview somewhere. So, yeah. So this looks good to me, and what I usually do, especially in real life, I usually don't do this. I'll just run it. But like if you're in an interview scenario, some companies don't allow you to run the code. They make you walk through the code step by step and talk through it, and like they make you take some example input, like I just did for you guys. Like I had all those like G's and B's, and I ran through it in the code line by line. Since I already did that, I don't have to do it. But sometimes you have to do that in interview situations. But since I've already did that, I advise that's something you do to help you understand the code better. I've already done it, but I'm gonna turn off invites for this. Sorry. But yeah, I've already done it. Are you working in SWE yet? Yeah, I've been working professionally for like 9-10 years now, so I'm old in the game, man. I'm definitely like, yeah, software engineer, a professional, like team lead. I was a manager at one point, got tired of that and went back to being a senior dev. But yeah, so let's run this thing, man. See what I get. So yeah, looks like it ran successfully for the case of 5. The bad version was 4, and I outputted the bad version as 4. In the case that the input was 1, the bad version was 1, and I outputted 1. That's what was expected. So yeah, this looks good. I'm gonna run it against Leetcode. I'm trying to see and make sure that I didn't put any. If you put a console log or anything in here, it'll mess up your runtime. And so what is the runtime of this before I even run it? It's big O of log n. And how do I know that? Because I just know the runtime of binary search. So there's just certain things. As much as folks like to say this is just, you just come up with this stuff from just being a good developer. No, this is stuff you have to learn and memorize and know. Like some of it. Some of the stuff you can get from intuition, but you got to have the building blocks and the pieces, because like a lot of the harder problems are built on binary search and more complex things like, you know, depth first search, breadth first search, dynamic programming, sliding window. Like all these techniques can get mixed together in some of these harder problems where it's not necessarily some new concept, but they like put 3 concepts together that you got to figure out. Recursion. Yeah, somebody mentioned recursion. For sure. So yeah, but let's run this, man. I don't want this video to just keep dragging on too long. And I don't know what the heck's wrong with Instagram, but I'm just gonna run this. See how fast that ran? People that was with me before, and I really didn't beat that much more, but it ran in a last time it ran in 10,000 milliseconds. 10,000. This time it ran in 117. That's like a 1,000% difference. So 10,000 versus 100 milliseconds. So in a real life application that you would do at work, like a lot of times people can't apply these problems to their real life jobs, and sometimes they don't. But sometimes it does. Like let's say checking isBadVersion, the call I was making to check the bad version. Let's say it was a database call, and I needed to make 1,000 of those calls because n was equal to 1,000. That's an expensive operation. That could take a database down if somebody accidentally puts 1,000,000 instead of 1,000 in there. It caused 1,000 database calls 1,000 times or whatever. And so by making the algorithm do binary search and be big O of log n time, you drastically reduce the calls to the database. In this example, this is just an example, and it's not real life, but it applies to real life as far as writing good algorithms that scale, especially when you're in real life. You're not going to be just writing a little piece of code. The piece of code is going to be calling an API, potentially. It's going to be calling database. Literally everything is calling an API and a database in a real life scenario at some point. Like at some point, there's some data. It's data processing that's happening when you're writing logic these days. It's got to be something you're doing, some work you're doing. So it can be expensive. So you need to write good algorithms for that. So yeah, I got that worked. And I got somebody's done this faster than me. I care, but I don't really care that much. I just care more about the actual improvement that I made on the time. I'm not trying to figure out the best unreadable solution that somebody could possibly come up with. Let me say, you should join my university as a professor. Thanks, man. That's a great. I'm thinking that's a compliment. So I appreciate that. But yeah, I hope people learn something from this. I appreciate people watching. I'm sorry on Instagram things weren't working, but it looks like everything's working on all my other channels. Twitch, appreciate you joining. Facebook people, appreciate you guys joining. Twitter and YouTube. And especially TikTok. There's a bunch of people on TikTok, a lot of comments on TikTok. I appreciate you guys for watching every time I do these. I hope you learned something. I'm going to be doing a lot. Somebody said, I see you. I was like, all right, man. I see you too, you know. But I appreciate y'all watching. I'm going to do these at least once a week. And I'm also going to be sharing more of my coding Some of y'all might have joined before where I was just showing I was working on a React Native project, and I was working on a React web app too, which was pretty cool, and people seemed to like that. Had a lot of discussion. Y'all were distracting me because I ain't getting no work done. I was just answering questions and talking and rambling. But that's cool because I had fun doing it. So I'll probably do that again soon. But yeah, appreciate you guys. I'm going to hop off of here. I'm going to post this video later for people that want to see it again. Follow me on all my social channels if you want to just see content like this and funny stuff and informational stuff, programming stuff in general. And with that, I say good night to y'all. Appreciate it.